Okay, so in this video, we're going to look at what we call the unit circle. And the unit circle is going to allow us to estimate values for sine and cosine. For example, what if I asked you what the sine of 45 degrees is? Well, we could put that into a calculator, or alternatively, using the unit circle, we'll be able to get an estimate for this for ourselves. And this is going to be quite powerful in later videos when we start to look at relationships between smaller and bigger angles inside of this unit circle. But to start off with, we've got to be able to generate our unit circle. So back to some sort of standard trigonometry that we know. Let's look at a right angle triangle. So here I have a right angle triangle. Okay, and I'm going to call my hypotenuse, I'm going to give my hypotenuse 1 unit of length. Okay, it might be 1 centimeter, 1 meter, whatever it is. I'm going to set that hypotenuse to have 1 unit of length. Well, if I look at, say, my angle down here, if I look at theta, right? Well, we know that the sine of theta, that's equal to the opposite over the hypotenuse, right? So the opposite divided by the hypotenuse. And well, what is my opposite in this case? Well, my opposite is just however big this length here is, right? So however long that is, it might be 0.7, it might be 0.8, right? That's going to depend on my angle. And well, it's just that bit in pink, that opposite bit, divided by my hypotenuse, which is just 1. And well, anything divided by 1 is just itself. So I just have the opposite here. So what that tells me is that the sine of my angle here, my sine of theta, well, I can get that by just simply measuring how long that pink line is there, right? How long my opposite side is. And that happens because I set my hypotenuse to 1. So I would just get a ruler out. I would make sure that this is set to 1 unit of length on my ruler, whether it's 1 centimeter, a meter, a millimeter, right, whatever it is. And then I just measure this line here in pink, and that's going to tell me what the sine of my angle is there. Similarly, I can calculate the cosine of theta, so the cosine of my angle. Now, I know that this is equal to the adjacent divided by the hypotenuse, right? Remember, these come from our acronyms SOHCAHTOA, right? And well, my adjacent is just this length here in blue. Okay, so I've just got my adjacent here divided by my hypotenuse, which I set to 1 unit of length, right? And well, because I set it to 1 unit of length, if I divide anything by 1, as we did previously, I just get that thing. So I end up with just my adjacent here. So I can measure the cosine of this angle by simply just measuring how long this adjacent side is, right? So I just get my ruler out and I measure how long this part here is in blue. So that gives us a little bit of motivation as to sort of where the unit circle is going to come from, right? And we'll get to the unit circle in a second. And the power of this sine and cosine, right? Now, if I take this right angle triangle, so if I take a unit circle, and I'll get a unit circle, up for us. So let me just, I have to use my select button. Let me copy this into this space. So here we have a unit circle, right? And what the unit circle is it's just a circle with a radius. See how the radius here is 1? So I'm not sure if you can see. That's a 1. That's a 1. Obviously, this is at -1 and at -1 here on the x-axis. So we've got a circle of radius 1. And well, if I set this line here, right? This line here, this x-axis. If I set that line to be 0 degrees, then I can measure the sine and cosine values by going around the unit circle in an anti-clockwise direction, right? So we're going up above this. So for example, if I measure, say, 30 degrees, 30 degrees might look something like that, right? Very roughly. We'll say that there is 30 degrees, right? And well, I know the length of this line here that I've drawn to the radius of the circle, right? That has to be 1 unit in length. So that is 1 because of the radius of my circle I've set to 1. And well, if I connect this triangle up, right, with some blue lines like that, I now have a right angle triangle with a hypotenuse equal to 1 unit of length. Right? So what I've done is, by this unit circle, I've created this right angled triangle inside of my unit circle. So hopefully you can kind of see the relationship there. And well, remember what we said earlier. If I want to guess what the sine of this 30 degrees is, so sine of 30 degrees, well, I just measure how long this side is over here, right? I measure my opposite side. So this is the side opposite to my 30 degrees because it's equal to opposite over hypotenuse. And well, my hypotenuse is 1, so it's just the length of that opposite side. And well, if I want to measure the length of that side, well, I just come over here to my y-axis and I look at, okay, well, how long is this side? Well, it's about, what do we get here from our guess? We get about 0.45 maybe, right? And it actually turns out that the sine of 30 degrees is 0.5. So for us guessing what 30 degrees looks like, that's not a bad estimate at all, right? We can be pretty happy with that. Alternatively, you could use a protractor to try and maximize how accurately you can draw this 30 degrees. But eyeballing it, 0.45, 0.5, that's pretty good, right? Now, what we can do from here is we can go, okay, well, what about the cosine of 30? Well, the cosine of 30, that's equal to my adjacent divided by my hypotenuse. And because, again, my hypotenuse is just 1 unit of length, it's just equal to my adjacent. And my adjacent side is this side here. And if I want to measure how long that side is, well, I just come down to my x-axis. And I see it's probably at about, what, that's 0.8, that's 1, so maybe 0.9-ish, right? So probably at about 0.9. And I think it turns out that the cosine of 30 is about 0.86, 0.87. Let's check. So the cosine of 30, I've got a calculator here, it's actually 0.87. So we're very close. It's a pretty good estimate. Now, what I've done is I've kind of motivated this idea through a right angled triangle to kind of give you an idea where this comes from. But from here on in, all we need to remember is that for sine, we measure to the y-axis, and for cosine, we measure to the x-axis. Okay, now it did get a little bit complicated, right? And you might have to watch that through once or twice to really get your head around where this thing comes from. But from here on in, I just want us to remember that the sine we measure to the y-axis, and we do this because it's equal to our opposite length. And our cosine we measure to the x-axis. And I've kind of motivated the idea that we do that because we're measuring the length of our adjacent side. Now, if we look at a couple of more examples, if I take this unit circle here, right, and we'll pop it down here, and we'll take our statement. So if you can remember these, right, you'll be fine. So let's take these statements that sine is that we need to measure to the y-axis and cosine is that we need to measure to the x-axis. Remember, my 0 degrees just starts on my my x-axis there, right? And, well, if I want to measure, say, 60 degrees, so 60 degrees might look something more like that, right? Because then I've got that would be a 60 degree angle from the x-axis. Well, I can measure the sine of this value by going over to the y-axis, and I get about 0.85-ish, right? And I can measure the cosine of this value by going down here, and I get, what do I get there? About 0.55, right? So this would be my sine, and this would be my cosine. And you could check these in a calculator and see how close you are, right? Now, furthermore, on the unit circle, I can create more angles. And an important note is that we have these different quadrants. So this is 90 degrees here, right? Because we would go from 0 up to 90, and then we'd go around to 180 degrees, and then around to 270 degrees, and then around to 360 degrees again, right, which lies on my 0 degree line. So these are the same, right? And well, I could cycle around again. So I would go to 450, right? And then I'll go to 540. And I could keep going around further and further, right? And I'm just going to end up cycling around this unit circle. And as a little bit of motivation for that idea, and we'll come later to look at these sine and cosine graphs, these sine and cosine graphs actually cycle like this. And that, they cycle, right? Oh, it won't let me draw it. But that comes from the idea that we're rotating around this unit circle, right? And if I go, so 360 is actually the same as 0. So I get the same output value. And we just go around in loops. And that's what we see on the graphs. But back to our point about sine and cosine on the unit circle and estimating these values. What if I want to do, if I call this, and I should probably made this point earlier, I call this quadrant 1, and we do them in Roman numerals. Call this quadrant 2. This quadrant 3, and this quadrant 4. So we measure up from the x-axis going in an anti-clockwise direction, and we go through the quadrants 1 to 4 respectively, right? What if I want to go outside of these quadrants? Well, let's look at, say, maybe if I draw out to here, right? So that angle there, what's that angle in total? Well, that's probably maybe 90 degrees plus maybe 20 degrees, let's say, right? So let's say that's 110 degrees. So if I want to measure the 110 degree angle for sine and cosine, well, nothing changes. I just measure my sine value to the y-axis. So I get 0.9 for sine. And I measure the cosine value down to the x-axis. So I get about minus 0.4-ish, right? And that's going to give me my cosine value. So see how I've entered the negative region for cosine now because I'm in the negative part of my x-axis. Whereas the sine, I'm in the positive part of my y-axis. So nothing changes in terms of estimating these values. I still measure sine to the y-axis and I still measure cosine to the x-axis, right? But furthermore, what happens is if I venture around further into these different quadrants? Well, remember, any angle between 0 and 90 is going to go into quadrant 1. And well, if I draw that all the way to the unit circle, maybe I'll do it in a different color. I'm going to get a positive x-axis value, so I get a positive cosine value, and I'm going to get a positive y-axis value, so I get a positive sine value. And if I go out and I do this in the second axis, as we saw before, so second quadrant, sorry, if I measure the sine value, I'm still positive. But if I measure the cosine value, I'm now negative. Okay, so I've now gone into a negative cosine region. Likewise, the third quadrant, if I measure the sine value, I'm now negative. And if I measure the cosine value, I'm also now negative. And finally, if I do this in the fourth quadrant and I measure the cosine value, I'm positive, and if I measure the sine value, I'm still negative now. Right, so that gives you an idea of in what quadrants we're going to see positive and negative values for sine and cosine. But I'll re-emphasize that nothing changes depending on what quadrant you go into for estimating the sine and the cosine. You just draw the angle and you measure how far up the y-axis we've gone and how far along the x-axis we've gone will give us the sine and cosine measurements respectively. Right. There's a worksheet that goes with this, right, which will be attached, and you can have a go at drawing some of these angles yourself and estimating the sine and cosine values, okay? You might want to watch this part through just up the top here. You might want to watch this through maybe once or twice, right, just to fully understand and get an appreciation for where it comes from. But once you kind of put that to bed in your mind, really, we're just focusing on this bit down here from now, right? So it's just remembering the sine measures to y-axis and cosine measures to the x-axis.